My dear students, today I am going to teach you Latin square design and its layout. This is Latin square design and its layout. The principle of local control was used in the RBD, that is randomized block design, by grouping the units in one way, that is according to blocks. The grouping can be carried one step forward and we can group the units in two ways, each way corresponding to a source of variation among the units and getting the Latin square design. This design is used with advantages in agricultural field experiments where the fertility contours are not always known. Then the Latin square design eliminates initial variability among the units in two orthogonal directions. The layout of the design. You say the layout of the design. In this design, the number of treatments is equal to the number of replications. Thus, in case of M treatments, there have to be M by M, that is M square experimental units. The whole experimental area is divided into M square experimental units arranged in a square so that each row as well as each column contains M units. The M treatments are then allocated at random to these rows and columns in such a way that every treatment occurs once and only once in each row and each column. Such a layout is known as M by M Latin square design, and it is extensively used in agricultural experiments. Obviously, there can be many arrangements for an M by M LSD, that is Latin square design, and a particular layout in an experiment must be determined randomly. As an example, let us consider a 4 by 4 Latin square design. This 4 by 4 Latin square design for comparing 4 varieties of crop. We take a rectangular field divided into 4 by 4 is equal to 16 plots arranged in 4 rows and 4 columns. We represent the varieties by A, B, C and D, by A, B, C and D. Then the particular 4 by 4 LSD is, this is here in this side column and in this side rows, and we arrange the varieties in this way. This is D, C, B, A, C, B, A, D, B, A, D, C, then A, D, C, B. This is the layout. Fisher and Yates, the statisticians, have tabulated Latin square up to 12 by 12, and it is 4 by 4 layout of a Latin square design. Advantages of Latin square design. Number 1, with two-way grouping or stratification, Latin square design controls more of the variation than completely randomized design or randomized block design. This is the first advantage of Latin square design. Then LSD is an incomplete three-way layout. Its advantage over the complete three-way layout is that instead of M-cube experimental units, only M square units are needed. And number 3, the statistical analysis is simple though slightly complicated than for RBD. Even with missing data, the analysis remains relatively simple. And the last advantage is number 4, more than one factor can be investigated simultaneously and with fewer trials than more complicated designs. And this is the layout of Latin square design, and these are the advantages. Then in your next class I will give you the statistical analysis of M by M LSD for one observation per experimental unit.